In this lesson, we're going to learn how to factor polynomials. We will learn how to factor out the greatest common factor. We will learn how to factor by grouping, and we'll take a look at a few special cases of quadratic expressions. So factoring is simply undoing multiplication. We're going to be undoing the distributive property. So let's remind ourselves of how to apply the distributive property and what it looks like. So in our first example, we're going to multiply 6 times x minus 4 to get 6x minus 24. We distribute the 6 to both terms. Our second example, we're going to distribute 2, and this gives us 2x squared minus 8x plus 6. In our third example, we're going to distribute 3x. This gives us 3x to the third plus 6x squared minus 15x. So in this lesson, we will be given these type of expressions and we will be identifying the factors, getting back the original problem, the original factors. There are many strategies and types of polynomials in which we will factor. And the first case is going to be factoring out the greatest common factor, which is always the first thing you ask. You ask, is there a greatest common factor? Is there a number or expression that can divide into each term of our polynomial? So our first example, we have this binomial, and I notice that 3 can divide into 18x and minus 21. So we're going to factor out the 3, and this is going to be the greatest common factor. I like to show my work to make sure I get the correct answer. So I'm going to divide by my greatest common factor. So 3 is one factor. The other factor is going to be our expression of 6x minus 7. If I wanted to make sure that my answer is correct, I could distribute the 3 to my binomial to get back my original problem. So 3 and 6x minus 7 are the two factors of 18x minus 21. 3 is the greatest common factor. In our second example, we have a trinomial. I notice that 3 can factor into each of these terms. So I'm going to factor out a 3. I'm going to divide 3 into each term, and I'm left with 4x squared plus 3x minus 5. So my two factors of this trinomial is 3 and 4x squared plus 3x minus 5, where 3 is the greatest common factor. In our next example, we have a trinomial, and I notice that 4 can divide into each of these terms, as well as x to the first. Each term has at least a factor of x to the first. So 4x is my greatest common factor, and I'm left with x squared minus 2x plus 5. The two factors of this polynomial is 4x and x squared minus 2x plus 5. I know that I have factored completely because there's no common term of this remaining trinomial. No common factor of each of those terms. So let's do a few more. And before we move on, let's write this in our notes. If the leading coefficient is negative, like the example here, factor out the negative. So in this example, I am definitely going to factor out a negative, but also I notice that 3x can divide into both of these terms. So we're going to divide negative 3x, which is the greatest common factor. So bring your GCF out front, and then we're left with 7x plus 8. In our next example, I notice that each of these terms has a common factor of 6x. 6x can divide into each of our terms. 6x is the greatest common factor. We're left with 4x squared minus 3x minus 1. In this example, I notice that each of these terms has a factor of 9, and my leading coefficient is negative, so I must factor out a negative 9. So negative 9 is the greatest common factor, and we're left with positive 3x squared minus 4x plus 2. In this next example, each term has a common factor of 5x squared. 5x squared is the greatest common factor. So the two factors is 5x squared and 3x plus 4. These are the two factors of our original polynomial. Now you pause the video and try these. Then when we come back, we will go over them together. In the first problem, our leading coefficient is negative, so we're definitely going to factor out a negative, and it looks like negative 6 is the GCF. We're left with positive 3x squared plus 4x minus 1. Our next problem, we have the greatest common factor is going to be 3. I factor out the 3, and we're left with 8x squared minus 7x minus 6. Our third problem has a leading coefficient of negative, so we're going to factor out a negative 3. When we factor out negative 3, we're left with 5x squared minus 18x plus 6. I know that I'm completely finished because 5x squared minus 18x plus 6 has no other common terms, no other common factors, I should say. And let's take a look at our last problem. 72x squared plus 18x minus 36. So I do believe that 72 has a factor of 18 so it does. So our greatest common factor is 18. So the GCF is 18, and we're left with 4x squared plus 1x minus 2.